All right, so I think this is recording. Let's take a look here at problem number 11. We're given a function g of x, and we want to find the inverse function. Notice that they have restricted the domain. This looks to be the quadratic function we know is the graph of the parabola. What I'm not for certain is that is 3 the x-coordinate of the vertex? Well, let's rewrite this function and put it in vertex form. Right now it's in standard form. So I'm going to use the first two terms, x squared minus 6x. And I need to create a trinomial that is a perfect square. So half of negative 6 is negative 3, and negative 3 squared is 9. So I'm going to add 9 to this, and that will make it extremely easy to factor. It'll be a perfect square. Now, I can't just come in and randomly add 9 to an equation. So I'm going to turn around right here and turn right around and subtract it. If I add 9 and then subtract 9, I haven't changed the equation. It still has the same solution set. Now, I still have that plus 2. I can't forget it. And, of course, the domain has been restricted to be greater than or equal to 3. So that comes along with each line, even if I don't write it. That comes along for the problem throughout each step. So this function g of x can now be rewritten. I can factor that trinomial. Half of negative 6 was negative 3. So I have this binomial x minus 3 squared. And then negative 9 plus 2 is a negative 7. And x is greater than or equal to 3. So since this is a 1 out in front and that's positive, I know that the graph is a parabola that opens upward. I know that the standard form, what are we subtracting here? We're subtracting a positive 3. The x-coordinate of this vertex is 3, and the y-coordinate of the vertex, what are we adding? We're adding a negative 7. So I know that the y-coordinate of the vertex is negative 7. So this graph lies entirely above that negative 7 or at that negative 7. So I know the range of this is greater than or equal to negative 7. I don't necessarily have to write it in interval notation. I can just leave it in x and y. And let's come back and not use the function notation, but call it y. So if I'm trying to find the equation for the inverse, I want to switch the domain and range. I want to switch these variables x and y. So where I see a y, I write an x, and where I see an x, I write a y, including over here with the domain and range. The domain was x greater than or equal to 3, so now that's the range, greater than or equal to 3. This used to be the range, and now it's the domain. So x has to be greater than or equal to negative 7. All right, so I want to solve this equation for y. I want to get y by itself. I like to have my variable, the y is the variable of interest on the left. So I'm going to write that binomial on the left. I'm not really doing anything. And this inequalities come along for the ride. I'm not going to write them until when I get to my final expression. Let's get the term that has the y by itself, so let's add 7 to each side. To balance to get rid of this exponent of 2, I'm going to take the square root, and to balance the equation, I'm going to take the square root of the other side. I need absolute value symbols around that variable. And that's where that plus or minus comes from. It doesn't come from the right-hand side. It comes from the fact that we are taking a square root of a variable. All right, I'm going to shrink this up. So that plus or minus that we constantly are talking about, and I'm trying to remind you to put when you're solving an equation like this, y for an absolute value equation, this y minus 3 might be the opposite of the expression that's outside of the parenthesis, or it might actually equal the expression. All right, so this splits into two equations. You're just like, wait a minute, if I have for every x 2 possible y values, that's not a function. And they said that they want us to find the inverse function. Well, they've restricted the domain. We want y to be greater or equal to 3. Here, let's solve each of these for y. Let's add 3 to each side. So we have 3, and we're subtracting some positive amount because the principal square root is defined to be positive. So this equation, as x changes, you're making 3 smaller by subtracting a positive amount. And over here, as x changes, we're adding a positive amount to 3, so we're making it bigger. We want y to be greater than or equal to 3. It's never going to be less than 3. We're going to throw this one out. We're only going to keep this. So even though we took the square root of a variable that we thought would lead to 2 equations, one of the equations is never going to happen. We could just throw it out because the y always has to be greater than or equal to 3, and that's never going to happen with that equation. That equation is not true. It's never going to provide anything. So over here, this is what we have, and this is a function, so I can use my inverse function notation. Instead of using y, I can go back to that g, and we call it g inverse. And I really don't have to necessarily write the domain and the range here because it's the natural domain. X has to be greater than or equal to -7, and y has to, nothing is unnaturally restricted. See, normally with a quadratic function there, normally the x is all real numbers. That would be the domain. If I solve just a quadratic equation, that's always going to be my answer. But sometimes they tell me don't use all real numbers. For whatever reason, the author of this problem and this function restricted the domain, and we now see the reason they restricted it so that the inverse relation would be a function. All right, well, hey, hope that helps. I'll talk to you later. Bye.